Hi everyone. In today's video, we are going to learn two things. One is, what is this class imbalance problem? And second is, if we in real life face such a situation, how can we handle that with few lines of Python code? So let's first understand what is this class imbalance problem. And let's look at this diagram and assume that this represents a data set. So there are two attributes, attribute 1 and attribute 2, which are your independent variables or input variables. One of them you have plotted across x-axis, another across y-axis. And these blue points actually come from class 1 and these amber points comes from class 2, right? So this is a data set which is a binary classification problem. And you will agree that the frequency of these two classes are quite similar. Such a data set is called as a balanced data set. On the contrary, if you look at this particular data set and you assume that this is also such a scattered diagram, you will agree that this red class is occurring less frequently, which is called as the minority class or the rare class, and this blue class is occurring more frequently or called as a majority class. Now, a pertinent question is that why this should be a problem, right? Actually, the machine learning model also learns or also uses the same philosophy by which a student learns. So if I intend that my student shows equal proficiency in maybe trigonometry and algebra, I need to provide him with similar number of problems. If I give him 5 trigonometry problem and 100 algebra problems, and I assume that he will display similar proficiency, it is unfair, right? Same thing happens with a machine learning model. So it will learn the majority class better or the pattern of the majority class better and will not understand the minority class so well. Now, a question that can come to your mind is that, okay, we understand that class imbalance poses a challenge to the machine learning models, but does this occur in the real world? Of course. One very particular example is about fraud transactions. So you must be knowing that the entire community is going berserk on preventing frauds happening in these credit card transactions or financial transactions. And as a percentage of normal transactions, it is very, very small, right? Again, if you look at the problem of maybe intrusion detection, right? So network packets, there also the intrusion packets are much lesser compared to the normal packets, right? So this happens in real world, and two very simple baseline approach can be that I bring down the algebra problems, right, to the level of trigonometry problem. Okay, so the student is now not overwhelmed by the sheer volume of the algebra problems. So what is the problem with this? The problem is that there might be quite a good number of algebra problems which I'll miss out. And this approach, this baseline approach that we just talked about, is called as undersampling or downsampling of the majority class. Okay. Now, the other approach could be that resample these trigonometry problems, right? So I have only these 5 or 6 problems, right? So I will resample them, so repeat them and bring it to the level of algebra problems. So at least the model doesn't ignore it. Now the problem with this is that as you are giving the same trigonometry problems again and again to the model, instead of actually learning the patterns, it can even memorize the problem because you are feeding the same problem again and again. So kind of the same problem as overfitting. So here enters SMOTE. If you look at SMOTE, let's look at the acronym first. It goes like this: synthetic minority oversampling technique. So we were already doing minority oversampling. What we have added over here is synthetic, right? So we are not simply resampling and giving the same trigonometry problem. So what we are doing here? So there are simple steps And just for your information, if you want to learn more about the working of SMOTE and you want to read about it, we do have a blog in towards data science, as well as we have a YouTube lecture on how SMOTE works. Okay. Now a quick recap, quick summary. So in SMOTE, step 1, you select a point from the minority class. So in this case, maybe a trigonometry problem. In this case, maybe a fraud transaction. Then we select some k neighbors from its neighborhood, k nearest neighbors. Also, they need to come from the minority class. So they also have to be from this trigonometry or from this fraud class. Now we randomly select some from there. Okay, some neighbors. So in this case, there were 4 neighbors, k was 4. Out of them, 2 we have selected randomly. So how many we will select depends on how much synthetic observations I need to create or I want to create. So here what we are doing is, we have this already selected minority observation and we have selected 2 neighbors. We just draw a line, okay, and we pick any point which falls in this line. So this is not a repetition, but we have generated a new one. So it is like there are maybe 2 patterns of trigonometry problems so there are 2 problems, one from pattern 1, another from pattern 2. You are generating a third problem which has some characteristics of pattern 1 and some characteristics of pattern 2. So this will somehow make the student's knowledge, or at least prevent the student from mugging up. Okay, so that's how SMOTE works. Now let's look at how to import libraries and get started with a dataset which has this class imbalance problem. So we do our basic housekeeping, import pandas, matplotlib, numpy, and we also, like our previous videos, we create a list so which we can use to actually color different observations of a dataset based on if they are in different colors, different clusters or different classes. Okay, so let me run this. Right now, let's create a sample dataset. Pardon the spelling of create. So we have used a function called as make classification. This is a very useful data set, right? So you could have used any real world data set, but this actually allows you to experiment better. And anytime actually you are trying to come up with your own algorithm, own methods, this is a good idea to create certain patterns and test it out. Okay, so their make classification will help you. So make classification takes parameter like how many classes you want, how much well separated the classes are, weight. So we say that 5% comes from class 1, 95% from class 2. So this is the imbalanced class. How many features are actually of use, how many are redundant, how much noisy this problem is, and so on and so forth. So let us go and hit the execute button. The dataset is created. Let's now visualize by the scatter plot like the way we have seen earlier. So we are using this matplotlib, and we have used only 2 features over here, right? So we can plot, and then we are using the colors for separating the 2 classes. So if we take a look, so this is how it looks like. This red class is your majority class and this blue class is your minority class. Okay. All right. Now, as you know that we need to break our dataset into training and testing, right? So let's just do that. Import this train test split and generate both the training set and testing set. The testing set, we are keeping 30% of the original observations. So it is created. Let's do a quick count on how much imbalanced our data set is. So we are using a function of numpy which is called as bean count on ytrain, right? So it tells that one of the classes, so you can understand this blue class is there for 31 times and this red class is there for 669 times. Okay. So this is what you have in ytrain. Now let's do one thing. Let's fit a simple logistic regression classifier. So we are not doing anything. We are just importing this logistic regression. Then we are initializing it. We are fitting the model, and then we are doing a prediction on X test. So that's what we are going to do with these 4 lines of code. Okay, so it is fitted. Now let's see how it is doing. So we are firstly looking at confusion matrix, and we'll also look at classification report, which will have more details. So this is how it looks like. Okay, so classification report is not defined. I think this also I will need to import. So just hang on there. Okay, so this is the classification report, and I believe it is from the same sklearn metric. Okay, so now let me run this once more. Yeah, so you see that what has happened. Uh, if you just look at the classification accuracy, which will be apparent from this principal diagonal, you may think that okay, out of in 285 cases, I am right in or out of these 300 cases, I am right in 285 cases, high accuracy. But that is not actually telling you the correct picture. The correct picture is that you have actually, there were 19 from class 0, right? So maybe you can think that this is your fraud transaction, right? And what is happening, that out of this 19, you could actually identify 4 as fraud. Okay, so that is reflected in your recall, 4 by 19. However, this 4 you have predicted accurately, so that's why your precision is 1. On the majority class, you have done fairly well, and your F1 score is 0.97, which is just harmonic mean of these two numbers. So it's a very scary situation. You know why? Because you had 19 fraud transactions, right? Out of them, only 4 you could identify, right? So here, let's see how we can play around with SMOTE. So for that, you have a library called as Imbalance, Imbalance learn. Okay, from there we import SMOTE. And what we are going to do is we are simply going to do resampling on X-train and Y-train. Okay, so X-train and Y-train is your input, which is an imbalance data set. From there, we are trying to create a balanced data set using this synthetic minority oversampling. So let us run this. It's done. Now let's quickly look at the bean count. Okay, so now you'll see that you have oversampled and both the classes are now equal or same frequency. So let's create another logistic model, and the main code which is getting changed is that instead of training on that X train Y train, we are going to train on X underscore res, Y underscore res, which are your resample data sets. And then we are going to predict on same X test. I am going to look at both confusion metric and classification report. So let's run this. Okay. Now let's see what happens. Now you see that your F1 score of this class 1 has taken a hit. Okay. Overall accuracy also taken a hit, but your recall has significantly gone up. So that means, what this recall means, that out of the fraud transactions that are happening out there, you are able to catch 84% of that. So that's like 4 times increase, because it was 0.21 earlier, right? So this is what actually you want to achieve through a technique like SMOTE. Okay, now few small things about the parameters of SMOTE. So one parameter is sampling strategy. So basically it can take either as a float as an value, so which indicates that how much majority minority mix you want to create. So what is the ratio? And this is applicable only for binary classification, you can understand. And if it is a string, then basically you can specify the class targeted by the resampling. So you can say majority, minority, so on and so forth. K neighbors is another another parameter. So basically number of nearest neighbors you are using to construct the synthetic sample, right? Okay. Now it turns out that SMOTE also has a problem, and this is very interesting. Okay, so let's say the original pattern is like this, right? So this is the majority one and this is the minority one. And what happens is that there are some minority points which exist in the majority class as well. Okay, so when you are doing creating the synthetic points, you can create, so you can select a point from here and from here, and then you can get a point here. And as a result, you can create what you called as bridges. Okay, so this is a typical problem that happens with SMOTE. And there are several other algorithms like, ADASIN, borderline SMOTE, k-mean SMOTE, SVM SMOTE. So all of this actually put some restriction in terms of from where you are going to select this minority class. So from where you are going to sample this minority class. Okay. So maybe in our next video tutorial, we'll focus on them and discuss their principal idea. Bottom line is that all of them actually gives you different strategy of selecting from where you will take the minority class samples. Thanks guys for watching this tutorial, and if you have liked it, do share with your friends and put your questions. Okay, so let's all learn together. Thank you so much guys.